Disinfection is the term used to describe the treatment process used to destroy or inactivate disease-causing organisms. Sterilization is the eradication of all life forms. Water is not sterilized, it is disinfected, made safe to drink. Primary disinfection during water treatment is designed to kill harmful microorganisms before the water enters the distribution system. In addition, a disinfectant residual can be applied to the water that will be entering the distribution system to deter the growth of microorganisms and to protect against contamination in the system. There are multiple ways to disinfect water. These include heat treatment, as in boiling, ultraviolet radiation or UV, and chemical treatment such as chlorine. Boiling water on a large scale is economically impractical and may concentrate unwanted inorganic or chemical contaminants such as lead and nitrate. Ultraviolet light, or UV, is the newest of the generally accepted disinfection strategies. UV inactivates microorganisms by irradiating them with ultraviolet light, thus disrupting the metabolic activity and reproductive process of the organism, rendering them inactive or incapable of reproduction. Particulate matter, or turbidity, interferes with UV light, thus lowering the amount available for inactivating pathogens. Therefore, UV is usually recommended for use after water has been filtered. The most commonly used methods for disinfecting water are chemical treatments. Chemical disinfectants often used for treatment include chlorine, chloramine, chlorine dioxide, and ozone. The chemical chlorine has been used for many years as a disinfectant and oxidizing agent. When chlorine compounds dissolve in water, they are hydrolyzed immediately into hypochlorous acid and hydrochloric acid. Hypochlorous acid is a weak acid and consequently ionizes in water to a hydrogen ion and hypochlorite ion. The combination of hypochlorous acid and hypochlorite ion make up the free available chlorine, with the acid form being the stronger disinfectant and oxidant. Next is chloramine, also called combined chlorine. Chloramine is typically created by addition of ammonia to free chlorine already present in water. Like chlorine, chloramine has a proven track record. Operators add ammonia and chlorine to form monochloramine, or simply termed chloramine. While not a highly effective primary disinfectant, chloramine is an effective secondary disinfectant for maintenance of a residual in the distribution system. Chlorine dioxide is created by the reaction of chlorine and sodium chlorite, producing a reactive gas. Chlorine dioxide is a strong oxidizing agent that is highly effective in oxidizing iron, manganese, and color problems, along with some taste and odor problems. Chlorine dioxide is effective against bacteria and viruses. It does have some effect on Cryptosporidium, and it will kill Giardia, depending on concentration and the amount of contact time. A disinfectant that gained much popularity with water utilities in the 1980s and 90s is the powerful oxidizing agent ozone. Ozone occurs naturally, for example, in a lightning storm. Ozone has a distinct odor, but it is not stable in the lower atmosphere. Ozone is 3 molecules of oxygen. It is produced by passing air containing oxygen over an electrical discharge. When produced for drinking water treatment, ozone is bubbled through the water. Ozone is considered one of the most powerful oxidants and disinfectants available for drinking water treatment. The use of ozone gained popularity due to its effectiveness in killing and deactivating pathogens while not introducing chlorination byproducts. A powerful oxidant, ozone helps control color, taste, and odor. It is typically applied in the treatment plant at the beginning of all the processes or after sedimentation. A number of disinfectants are used for water treatment, and each has its own advantages and disadvantages. But disinfected water is essential over microbially contaminated water. The advantages for using chlorine are that it is a strong oxidant, simple for operators to use, maintains a persistent residual in the distribution system, and a long history of reliable performance. The use of chlorine is not without problems. Chlorinated byproducts, for example. People often do not prefer drinking water that has a chlorine flavor, and the use of chlorine gas can be considered hazardous and must be fully contained. Chloramine's advantages include little or no trihalomethane creation. It's simple to use, has a persistent residual, may better control biofilm, and has a proven history. Unfortunately, chloramine is a weak oxidant and can still cause some total organic halide formation. Chloramine is often associated with biological nitrification in distribution systems, which has its own concerns. Ozone is a strong oxidant that creates little or no trihalomethanes or total organic halide. No taste and odor problems are usually created, and many can be alleviated. While some byproducts are created, they are biodegradable, and ozone aids in the coagulation process. Ozone has a very short half-life, cannot be stored, and must be generated on-site and does not provide a residual for the distribution system. The generation and feeding is fairly complex and expensive, and because of the nature of ozone, special non-corrosive materials need to be used. Chlorine dioxide is a strong oxidant. There is little or no THM formation. It can be effective in controlling certain odor problems. Disadvantages include total organic halide formation along with chlorate and chlorite byproducts. On-site generation is required, and it leaves no residual disinfectant for the distribution system. Finally, ultraviolet radiation. Remember, UV is a disruptive light energy process and not a chemical treatment. UV acts as a strong disinfectant with little or no formation of disinfection byproducts. There are literally no taste and odor problems as a result of its use, and with enhanced procedures, it can be effective against certain odor problems. UV is an energy-intensive process when delivered on-site that creates no persistent residual in the distribution system. This requires UV to be augmented with a chlorine disinfectant.